Greetings and welcome to lesson 5.1, Ratios. So what does it mean to be a ratio? Ratio is of two numbers is a relationship between the two numbers. So it has meaning. It's more than just a fraction, although we look at it in terms of a fraction, and we can do math on it like fractions. But it's more than that. It has meaning behind the numbers. It also has meaning behind the order of the numbers. So, the ratio of two numbers is a fraction where the first number in the ratio is the numerator, and the second number in the ratio is the denominator. So here's the definition. If A and B are any two numbers, then a ratio of A to B is A over B. And we actually read it as A to B. And of course B we don't want to be 0. And therefore if the order matters, then the ratio of B to A will be B over A. And we don't want A to be 0 this time. Okay? So a ratio, the order matters in which you're saying it. Because it's not just numbers that we're going to be talking about, it's going to be items. Like 5 apples to 3 lemons. You know, it's going to be a relationship between two items. And we can expand that to 3 items and 4 items and 5 items. But let's concentrate on 2 right now. Okay, so a ratio is a relationship between two numbers indicating how many times the first number contains the second number. So it's a relationship. Here's an example you could probably imagine. Let's say you have a fruit bowl on the counter and that fruit bowl contains 8 oranges and 6 lemons. Then the ratio of oranges to lemons is 8 to 6. We can write it as 8:6, and the equivalent amount of that ratio would be the ratio of 4 to 3. So we always want our ratio to be in lowest terms. So 8 to 6 is the ratio of 4 to 3. So let's express the ratio of 16 to 48 as a fraction in lowest terms. Well, initially, let's set up our fraction 16 to 48, and then we need to reduce this to lowest terms. Now, if you don't see it immediately, you can just start dividing by 2 certainly goes into both of those. Okay, 16 divided by 2 is 8. 48 divided by 2 is 24. Again, looks like 2 lives in both of them. 8 divided by 2 is 4. 24 divided by 2 is 12. And either you can reduce immediately by 4 if you see it, or do another step of 2. 4 divided by 4 is 1. 12 divided by 4 is 3. So the ratio of 16 to 48 in lowest terms is 1 to 3. Now I did not say 1/3. I did say 1 to 3. It is a relationship between those two numbers. So it is not just one number of 1/3. It is 1 to 3. And how do you know it's not 1/3 versus 1 to 3? The context of how it's expressed. If you specifically say what is the ratio, then it should be something to something. Otherwise, it is 1/3. Now we can do math on this 1 to 3 just like we can a regular fraction, and we'll see that coming up. But just keep in mind how we say it, how we express what this number means is a little bit different now. It's a 1 to 3 ratio. Let's try another example, but this time a little bit more complex. Give the ratio of 2/3, in this case it is 2/3 the number, to 4/9. Well, let's write it as a fraction in lowest terms. So let's start off with our regular ratio of 2/3 to 4/9. And you can think of this as division at this point. Remember, these are just numbers, so I can treat it as numbers. So I can say 2/3 divided by 4/9. We'll eventually write it as a ratio, but right now let's do the math on it. And then we're going to not divide by a fraction, but multiply by the reciprocal of the fraction. 2/3 times 9/4. I like to reduce beforehand, so I'm going to go ahead and reduce. 3 goes into 3 once, 3 goes into 9 3 times. 2 goes into 2 once, 2 goes into 4 twice. So the ratio of 2/3 to 4/9 is 3 to 2. 3 to 2. Another thing we need to know about ratios is you always express the ratio in terms of whole numbers. And generally, because these are counting numbers, they are always going to be positive. You wouldn't have a negative 3 bananas to 2 pineapples. You wouldn't have a negative amount of something. Ratio has to be in terms of something that exists, right? Otherwise, it's not a ratio. It's just numbers. So 3 to 2 is how we say it, not 3/2. Okay, I just want to walk through some examples, some quick examples. So if you're given the ratio of 25 to 35, first you could write it as a fraction as 25 to 35, and then in lowest terms as 5/7. Now this is much different than the ratio of 35 to 25, because you would write that as a fraction of 35 to 25, and therefore the reduced fraction is 7 to 5. Order matters. If we have something like 8 to 2 in fraction form, that would be 8 to 2. But in lowest fraction form, that's 4 to 1. Now we're going to be getting into why is this useful. Well, let me jump to something like 4 to 1. Let's say you're making lemonade, and you want to know how many parts of sugar to 1 part lemon juice. Okay, so you have this recipe, and it says it's a 4 to 1 ratio. But it doesn't give you really any more information than that. Then if it's worded as sugar to lemon juice, then it would be 4 parts sugar to every 1 part of juice. So what if you had 2 parts juice? Well, then you would need 8 parts sugar. If you had 3 parts juice, you would need 12 parts sugar. That's much different than if it was juice to sugar ratio, then you would need 4 parts juice to 1 part sugar, and you would have a very tart drink. Right? So think about the order, think about what it really means. I mean, it's not just numbers anymore. It has meaning behind the numbers. Okay, let's try another one. 1/4 to 3/4. 1/4 to 3/4 written as fraction form is 1/4 to 3/4. And if we reduce this, it would be 1 to 3. Here's a little trick. When you have fractions with the same denominator, and you are going to do, in essence, division, you basically can eliminate the denominators, and what's left over is going to be your fraction. Because ultimately, in the process of division, you're going to flip the second fraction, and then the denominator of the first becomes the numerator, or the denominator of the second becomes the numerator, and therefore you have the same number on top and bottom, and it will always cancel out. So a quick trick is if it has the same denominator and you're dividing, just look at the numerators and that's going to be your result. Okay? Make sure you reduce if needed. Okay, 0.6 to 1.7. Again, the fraction is going to be 0.6 to 1.7, but ratios are always in terms of whole numbers. So we need to reduce this to lowest terms. 0.6 I can multiply by 10 to get a 6, and 1.7 I can multiply by 10 to get to 17. You can also write it as, well, 0.6 is 6/10, and 1.7 is 1/17, And we're in that same situation where we have 6/10 to 17/10. Ignore the denominators and you're left with 6 to 17. Right? So depending on how you want to look at decimals, either write them as fractions and then convert them over to the lowest terms, or multiply each by 10 or 100 or whatever you need to move that decimal in both to come up with whole numbers. Ratio are always in whole numbers. In sports, there are a lot of numbers. Numbers. There's ratios and percentages and all of that good stuff. So let's take an example. During a basketball game, basketball player makes 12 out of the 18 free throws that he attempts. What's the ratio of number of free throws he makes to the number of free throws he attempts? So the first number will be the free throws that he makes, which will be 12. The second number is the number of free throws he attempts, which is 18. And now let's reduce this ratio. We can divide by 2 for both. That's 6 to 9. We can also divide by 3 to both. That will be 2 to 3. So how is this information helpful to know? Well, let's expand this concept. Let's think about if he didn't attempt 18 free throws. Let's say he attempted 21. What could we expect that he could have made? Okay. Well, 3 goes into 21 7 times, and 2 times 7 is 14. So if he tries 21 times, we expect he will make 14 of those free throws. Okay. Let's expand it a little bit more. Let's say he, over a course of, 12 games, he makes the attempts of, let's see, let's say he makes 90 attempted free throws. Then how many that can we expect that he makes? Okay. Well, 3 goes into 90 30 times, and 20 times 30 is 60. We can expect that he will make 60 of the 90 attempts. Now, how is that even relevant? Well, we want to know if we want to keep this player or not. And if his ratio is high enough, then hey, he's for the game. But if we look, and when we first hired this this basketball player, and he was at the ratio of 2 to 3, and then we calculated a little bit later and he's down to 1 to 3, do you think the basketball player will still be on the team? Probably not. So ratios are very helpful in making judgments. It's very helpful to see how the relationship of two things holds. Is it constant? Does it change? Is it worthwhile to keep something? Ratios are good for those instances, and then some. That's just a few examples. All right. A solution of alcohol and water contains 15 milliliters of water and 5 milliliters of alcohol. We want to find the ratio of alcohol to water. When it's talking about a solution just means a mixture. You can think of this as not just alcohol and water. Maybe it's lemon juice and water. Maybe it's rum and Coca-Cola. Maybe it's, if you're a bartender, you deal with rum and Coca-Cola. You deal with, what do they call them? Screwdrivers, where it's vodka and orange juice. There's these solutions, mixtures of liquids. Even something as simple as lemon juice. Well, you have sugar, you have lemon juice, and you have water. That's it. That's how you make lemon juice. And it's a mixture, a solution of those three items. So let's talk about this solution of alcohol to water. We know our ratio is going to be alcohol to water, and therefore I have 15 milliliters of water, and we have 5 milliliters of alcohol. That means it's going to be, let's divide by 5 for both of these, a 1 to 3, excuse me, a 1 to 3 ratio. Okay, 1 to 3 ratio. What if I asked you, what is the ratio of water to solution? And you might be asking, okay, where did this solution come in? The solution is just all of it. Water, we know, is the 15 milliliters. The solution is both the alcohol and the water. The alcohol was, the water was 15 and the alcohol was 5. Therefore, it's a total of 20 milliliters of solution. Let's divide by 5 for each of those. That's 3 to 4 ratio. There are 3 parts of water for the whole entire solution of 4 solution. It does matter the order. So if I said, what is the ratio of water to alcohol? That's going to be 15 milliliters to 5 milliliters. In other words, a 3 to 1 ratio. Right? So order matters, and when you're talking about solution, it just means the whole thing. Right, on a website, fueleconomy.gov, it provides some information about the carbon footprint scores of cars. The carbon footprint is a measure of the tons per year of carbon dioxide produced by driving the car. Use the carbon footprint below to find the ratio of the carbon dioxide output of a Chevrolet Suburban and to that of a Honda Civic, and we're going to round to the nearest tenth. Now, keep in mind that you can use your gut instinct here. What do you think is going to be polluting the air or producing more carbon dioxide? The Suburban or the Civic? Well, the Suburban is probably twice the size of a Honda Civic. So I'm going to guess that the Suburban produces more carbon dioxide than the Honda Civic. Not saying that the Honda Civic doesn't produce any, it does, but it will probably produce a lot less. So going to the website, you can find that the Honda Civic produces 4.6 tons per year of carbon dioxide, and the Chevy Suburban produces 8.6. Well, let's see of Suburban to Civic. So the Suburban is 8.6. The Civic is 4.6, but remember we deal with whole numbers here in a ratio, so we need to multiply both of those by 10, giving us 86 to 46, but then we want to reduce that to lowest terms, 43 to 23. So maybe you're a green conscience person and you want to make sure that your next car that you buy is a green car, then maybe you would do some comparison like this to see which car is best for you. Besides maybe a skateboard. You're trying to look for a car and not a skateboard or some other manual mobile device. All right, that's it for this lecture. Until next time, be seeing you.